Okay, so please take note. Okay, identify how many stereoisomer that you can form. Okay, for this molecule. Now, the first thing that you need to notice is, okay, we are going to find out how many double bonds, okay, that can give rise to your cis and trans. Okay, so for now, the same. Okay, this particular CH2. Okay, this double bond. Okay, because the carbon is attached to the two same group. Okay, therefore, okay, I will not include this double bond. Okay, because this is not going to give you any cis and trans. Now, for this double bond, I will include. Why? Because the carbon that has the double bond is going to be attached to two different groups. Okay, you can see this carbon is attached to two different groups. Now, I have one double bond. Okay, and then I also ask you to look for, okay, to look for the chiral center. Now, the chiral center that you need to look is going to be the one that has four different groups, and you will see that this is going to be a chiral center. Okay, this is going to be one chiral center. Okay, or one optical like chiral center that can give rise to optical isomer. Now the formula, okay, I want you to use, okay, this formula. Okay, 2 to the power of n. Okay, 2 to the power of n. N represents, okay, both. Okay, you can include the number of double bond, okay, that can give rise to cis and trans, and also the number of chiral center that you have. So in this case, the number of double bond is 1, number of chiral center is 1. You just put n equals to 2 there. Okay, you are going to get 2 to the power of 2, total 4. Now, I don't want us to think so much on this, okay, but I'm just going to explain using the formula. Okay, but if you want to read more on this, okay, there's a lot of areas that you can read about this, but it's not in our syllabus. Okay, so please take note. This is one additional stuff I'm teaching. Okay, on top of this double bond, if you have chiral center, then you just put it inside the formula, the n. Okay, just put it inside the n, and you will get the same answer, which is going to be 4, but the working was different. Yeah, the working was different. Why the working is different? Because you can see here, I predicted, okay, we predicted in the previous lesson that this is going to be 6, okay, but the answer is not 6. Okay, I'll show you why. Okay, when we use this formula, okay, we are going to use 2 to the power of n. You see that this double bond, okay, can give rise to cis and trans. This double bond can give rise to cis and trans. And we also know that this carbon over here is going to be a chiral center. So the number of n is going to be 1 over here, 1 over here, a chiral center over there. So the n is going to be 3. So this is going to be 2 to the power of 3, which is going to be 8. So this is going to be the number of stereoisomers that you can get for this molecule. Now, whether you need to draw and show them all the stereoisomer and so on, if you have that kind of question, okay, the answer to that question is very simple. You are not required to draw any of those molecules. Okay, they will not ask you to draw. Okay, they will not ask you to draw. So this is going to be what I want to teach you about the number of stereoisomer. Now, before I